This is Lesson 6.8, Systems of Inequalities. Your objectives are to graph systems of linear inequalities and solve systems of linear inequalities by graphing. The solution of a system of inequalities is the set of all ordered pairs that satisfy both inequalities. If you graph the inequalities in the same coordinate plane, then the solution is the region where the graphs overlap. Remember your dotted or solid lines, and remember to shade above or below. Where the graphs overlap, that's the final answer. Solve each system of inequalities by graphing. Number 1. Y is greater than -1 and x is less than 0. We'll graph each of these, and the solution is where the graphs overlap. For y is greater than -1, when y is a number, that's just a horizontal line through that number. So we have a horizontal line through -1. And since it's greater but not equal to, it's a dashed line. We'll do that one in red. So we have a dashed line through -1, horizontal. Y is greater, so we will shade that above. For x is less than 0, when x is a number, it's a vertical line through that number. And since x is less than but not equal, we have a dashed line. That one is blue, vertical line through 0. And since x is less, we can't do above or below, but we can do left and right. When x is less, it's to the left, so we'll shade this one to the left. The solution is where these overlap. Look where red and blue come together, and they make purple. So that region is the solution. Number 2. Y is greater than -2x plus 2, and y is less than or equal to x plus 1. The first inequality, let's graph it. It's solved for y, so we can graph it using slope-intercept form. It has a y-intercept of 2, so we'll put a point there. And its slope is -2. You can put that over 1, and we'll rise down 2, right 1, and put a point there. Y is greater but not equal, so it's a dashed line. And since y is greater, it's shaded above. For the second one, it's also solved for y and in slope-intercept form. It has a y-intercept of 1, so we'll put a point at 1. The slope is the number in front of x, which isn't written, so it's a 1. And we can put that over 1. We'll rise up 1, right 1, and put a point. It's less than or equal to, and since it's equal, that's a solid line. And since it's less, it's shaded below. The solution is where the graphs overlap, and that's where red and blue make purple, in that region to the right. Number 3. Y is less than x plus 1, and 3x plus 4y is greater than or equal to 12. The first inequality is solved for y, so we can graph it with slope-intercept form. We'll use red. The y-intercept is 1, and the slope is 1, which is 1 over 1. So we can rise 1 and run 1. Since y is less than but not equal to, it's a dashed line, and less than is shaded below. The second inequality, we need to solve for y before we can graph it. We need it in slope-intercept form. Subtract 3x from each side. And instead of saying 12 minus 3x, say negative 3x plus 12, because you want the x's to come first. Then divide both sides by 4. The 4's cancel on the left, leaving y. And negative 3x divided by 4 is negative 3/4 x. 12 divided by 4 is 3. Now I can graph that with blue. It has a y-intercept of 3 and a slope of negative 3/4, so we'll rise down 3, right 4. Y is greater than or equal to, since it's equal, it's a solid line, and since it's greater, it's shaded above. The solution is where they overlap, which is right there. Remember, if an inequality is not solved for y, solve it for y and get it in slope-intercept form. Number 5. Y is less than or equal to 2x plus 3, and y is greater than or equal to negative 1 plus 2x. The first inequality is in slope-intercept form, so we can go ahead and graph it, and we'll use red. The y-intercept is 3, and the slope is 2, which is 2 over 1, so we'll rise 2, run 1. Y is less than or equal, and since it has the equal part, it's a solid line, and it's less than, so it's shaded below. The second inequality isn't in slope-intercept form, so let's make sure everything is in the right place. It's solved for y, but the right side is backwards. The x's should be first, so rewrite that. 2x minus 1. Instead of negative 1 plus 2x, change it to 2x minus 1. The y-intercept is negative 1, and the slope is 2, which is 2 over 1, so we'll rise 2, run 1. It's greater than or equal, so it's a solid line, and greater is shaded above. These graphs overlap where red and blue come together to make purple, and that's the region in the middle. In real-world problems, sometimes only whole numbers make sense for the solution, and often only positive values of x and y make sense. So, when you solve real-world problems, graph them, and make sense out of it, most of the time they will be positive numbers. Not every time, but most of the time. Once again, the solution is where the graphs overlap. For each exercise, graph the solution set and list 3 possible solutions to the problem. Number 1. Mr. Flowers is on a restricted diet that allows him to have between 1,600 and 2,000 calories per day. His daily fat intake is restricted to between 45 and 55 grams. What daily calorie and fat intakes are acceptable? Well, let's look at the clues. His calories are between 1,600 and 2,000. So there's where the calories are 1,600, and there's where the calories are 2,000. It's between those, so we'll shade in between. Fat intake is between 45 and 55 grams. When fat is 45 grams, it's right there. 55 grams is right there. So his fat intake is between those. So we'll shade in between those two lines. The solution is where those overlap. Where red and blue overlap to make purple is in that region right there. Now, pick 3 possible solutions. There are many, many answers you can have, actually an infinite number of answers here. So you can pick any 3 points that are in the purple area. So let's pick some points. That point right there. What are the calories and fat grams for that point? Calories are about 1,700, and it's about 46 grams of fat. There's another point. I'm just selecting various points in that purple region. I could put it anywhere. I put it there. That has about 1,800 calories, and fat is probably around 54 grams. We need one more point. We'll pick it right there, I guess. That has about 1,900 calories, and it's right about 50 grams of fat. I could have picked any 3 points. I selected those 3, and I estimated as close as possible to what the value probably was for calories and fat. So graph the lines, shade in the proper direction, and the solution is where they overlap. Then finally pick 3 points in the solution and say what they mean. Number 2. Maria had $150 in gift certificates to use at a record store. She bought fewer than 20 recordings. Each tape cost $5.95 and each CD cost $8.95. How many of each type of recording might she have bought? Well, we're looking for how many tapes and how many CDs, so those will be the variables. Let's have X be the number of tapes, and Y will be the number of CDs. And you can see in the graph, tapes is the X-axis and CDs is the Y-axis. Now look for the clues in the question. She bought fewer than 20 recordings. So the number of tapes plus the number of CDs has to be less than 20. It can't be equal to 20 because the question says it's fewer than 20. Let's solve that for Y and get it in slope-intercept form. Subtract X from each side, and you get Y is less than negative X plus 20. And let's graph that. The y-intercept is 20. The slope is negative 1 over 1. So we'll rise down 1, right 1. It's less than, but not equal, so it's a dashed line. And less than is shaded below. Now let's look for more clues. She had $150 in gift certificates, and the tapes cost $5.95 and CDs cost $8.95. So if you do the tape cost times the number of tapes and the CD cost times the number of CDs, that can't go over 150. So I know that 595X plus 895Y has to be less than or equal to 150. It can be equal to 150 because she does have $150 in gift certificates. Let's solve this for Y. Subtract 595X from each side, and you get 895Y is less than or equal to negative 595X plus 150. Remember to put your X's first. And then divide both sides by 895, and you get y is less than or equal to, and we're going to ballpark this one. Since negative 595 is almost negative 6, and 895 is almost 9, we'll just make that the fraction negative 6 over 9, which reduces to negative 2/3. So it'll be negative 2/3 x. 150 divided by 895 is about 16.75. Now we can graph that. So we'll graph that with blue. The y-intercept is 16.75, which is about right there. To rise down to right 3 puts you about right there. It's less than or equal, so the equal gets a solid line, and less than is shaded below. These overlap in the purple area, and now we'll pick 3 points and determine how many tapes and how many CDs that could be. So the point right there, that's about 2 tapes and 2 CDs. Another point could be right there. That looks like 10 tapes and 5 CDs. Finally, we'll pick a point right there. That's 5 tapes and about 12 CDs. So look for the clues in the question, graph it, and then pick 3 points and say what those points mean. So when you graph inequalities, make sure that the inequality is in slope-intercept form. Remember to use a solid or dashed line and shade above and below, and your solution is where the graphs overlap. When you have a story problem, use the clues from the question, make your system and graph it, and then pick 3 points and say what those points mean, where they intersect on the x-axis and y-axis, and how many of each type you get.